Okay, it's time to discuss brown dwarfs, and specifically discoveries from the last few months, mostly made by the James Webb, that basically help us see these unusual objects in a very different light. And when it comes to James Webb Space Telescope, investigating brown dwarfs is actually one of its primary missions. Mostly because, unlike other objects in the galaxy, they're predominantly only visible in the infrared light. Because of their overall small mass, they generally only produce infrared emissions with occasional radio waves and some X-rays. But in order to physically detect them, we need infrared light, especially brown dwarfs that are much smaller, much lower in mass, bordering on basically being giant planets. But because these are such unusual objects and because we don't actually have them in the solar system, yet they seem to be essential in answering questions about star formation and even planetary formation, trying to figure out exactly what's going on in them and trying to find more of them is of course really important. Although interestingly, up until mid-90s, these were basically just completely theoretical. Actually, one of the reasons they're known as brown dwarfs is because back in the 80s, some of the astronomers realized that if you have a bunch of leftover mass that is unable to produce a star, you're probably going to end up with some kind of a small object that's not really a star and not really a planet. And they actually thought that maybe, in terms of color, it might appear kind of brown. So they named them brown dwarfs. And then, in the late 90s, these objects were finally confirmed. And this was all thanks to infrared observations from the iconic Wide Field Infrared Survey Explorer, or WISE. The telescope that basically discovered most of them around us, and even discovered some of the closest objects to us only a few light years away. And even though they're kind of close to us, they're only visible in the infrared. And since we're talking history, here's the first one ever found. TEED 1. This was discovered back in 1995. But even though it's been like 3 decades now, we actually still have so many questions and barely understand them at all. Yet in just the last few months, there have been quite a few different studies and a lot of different surveys trying to discover even more about them and trying to find some of the strangest ones as well. And when it comes to unusual and strange brown dwarfs, there have been some exciting discoveries. But in terms of answers or explanations, yeah, that's not really happening in this video. There are actually more questions than answers. And so anyway, very recently there was a very large survey looking at all of the nearby stars that essentially discovered that most stars around us are approximately 0.4 solar masses in mass on average, which actually suggests that the Sun itself is much larger than usual. But in that survey they also discovered that for every 4 stars out there, there's always at least one brown dwarf. Sometimes orbiting by itself, sometimes with a partner, and sometimes even containing its own planets. And though most of those brown dwarfs discovered were actually relatively massive, there's a kind of a subclass of brown dwarfs that's even more mysterious. So yeah, basically there's like a mystery within the mystery. They're sometimes known as the sub-brown dwarfs, and they're usually the dimmest and the coldest objects out there, making them extremely difficult to detect. And they're also unlikely to be brown. Modern studies suggest that they're probably either magenta or dark purple in color. And as of early 2024, 27 have been officially confirmed, and approximately 30 more are unconfirmed candidates. And it's actually unclear if there are so few of them because they're rare or because they're so difficult to detect. Maybe a bit of both actually. But if they're close enough to us, they are visible and detectable by infrared observations. And that's essentially what happened to the brown dwarf you see right here. Originally this was discovered approximately 10 years ago, and it's known as WISE 0855. It was discovered by Kevin Lohman and his team, and was very unusual for one reason. It seemed to be extremely cold. And it seemed to contain less than 10 Jupiter masses. Kevin Lohman is actually famous because he does have the very famous Lohman system named after him. It's a binary brown dwarf system relatively close to us. But this system is also very close. It's just over 7 light years away from us, making this one of the closest stars, or I guess star-like objects, next to the solar system. And although this was discovered over 10 years ago, they actually wanted to take a look at it again using the James Webb Space Telescope. Just to understand what's going on here, and just to see if their predictions were correct or maybe wrong. Specifically, they wanted to focus on the composition and the potential observations from the atmosphere. Now, because the system is so close to us, all of the observations by the James Webb were extremely accurate, but still not accurate enough to know its exact mass. Right now the estimates are between 3 to maybe 10 Jupiter masses. But the scientists here were able to recalculate the overall temperature. The surface temperature is about 285 Kelvin. That's basically 12 degrees Celsius or approximately 53 Fahrenheit. And that's basically a typical springtime temperature in northern US. But naturally we expect this to be some kind of a gas giant, so as you go deeper and deeper, it probably gets toastier and toastier. But that's not really the important part. The important part was the analysis of the atmosphere. Here, their predictions suggested that it's probably going to have things like phosphine and potentially a lot of clouds similar to Jupiter, because they expected this object to be kind of similar to a gas giant. But the James Webb found no clouds, no phosphine, no water ice whatsoever, meaning that it very likely looks extremely different from Jupiter or Saturn, or was possibly formed in a different cloud or possibly from different material, and had very different origins. In contrast though, a different study investigated this brown dwarf, WISE 1828. Another really cold brown dwarf, but farther away at 32 light years, that's possibly just a little bit warmer. Possibly 27 degrees Celsius, 81 Fahrenheit. And in contrast here, James Webb found water vapor, methane, ammonia, various types of nitrogen isotopes, carbon monoxide and carbon dioxide, hydrogen sulfide, and even found abundances of carbon, oxygen and sulfur that seem to be much higher than the Sun. Which is quite an intriguing contrast. Both objects are very similar in mass, very similar in temperature, and actually very similar in a lot of different things that we see on them, but the overall chemical composition seems to be entirely different. One is very enriched in a lot of different molecules and potentially has a lot of clouds. One seems to be very poor in everything and seems to have nothing. And there's really no explanation for why and what's happening. Which suggests that even when it comes to brown dwarfs, there might be a lot of extra classifications and additional categories, maybe based on their origin or based on how they evolve. And because in the past, researchers even found orbiting exoplanets around similar brown dwarfs, with some just a little bit bigger than planet Earth, trying to understand what's happening around these objects is of course important for exoplanetary and astrobiological studies as well. I mean, just the fact that the temperature here is so close to planet Earth, and a lot of these objects contain organic molecules required for life, for all we know the planets orbiting them might be seated in all of these materials, creating really interesting conditions for extraterrestrial life. But that was just the first discovery. One of the other discoveries that we've discussed previously is even stranger, mostly because it takes us to a new limit for brown dwarfs. And this was based on observations from a star cluster known as IC 348, roughly around 1000 light years away from us in the constellation of Perseus. And here, by looking at various star-forming regions, James Webb discovered several objects 3 to 4 times mass of Jupiter, but strangely enough, with a lot of properties and appearance of a typical brown dwarf. All of them approximately 5 million years old, and all of them containing extremely similar chemical properties to a planet like Saturn, a lot of hydrocarbons, and actually quite a lot of complex chemistry. Yet their mass was about 3 to maybe 8 masses of Jupiter, the least massive brown dwarfs ever found. And so here, it's not entirely clear what we're looking at. Are these just really hot baby planets with really high temperatures of 800 to 1500 degrees Celsius that are just going to cool down over time in the next few millions of years? Or are these really the least massive brown dwarfs ever found that basically redefine our definition of these strange objects while also showing us how they most likely form? Inside very large molecular clouds from basically leftover material. And so here once again there's really no answers yet, just observations and of course more mysteries. But the observations from the next brown dwarf might have an explanation. Okay, so when it comes to James Webb, one thing that it does really well is basically provide us with spectroscopy of various objects out there, which then allows researchers to discover what sort of elements are inside. And so here in this new study, the researchers were looking at another brown dwarf, W1935, located 47 light years away from us, whose temperature was about 200 degrees Celsius, so just a little bit warmer than some of the other ones, but not by much. This object was only discovered in 2019, and so there's still not much we know about it. And here the researchers predicted that they are going to observe methane. and specifically they're going to observe absorption lines of methane. Or in other words, they're going to be seeing these very dark patches corresponding to the frequency produced by methane. But instead they saw the opposite. They actually saw emission lines produced by methane, implying that for some reason this unusual brown dwarf had methane emitting light. Or basically methane was kind of glowing. And this by itself was kind of difficult to explain. Nobody was certain what's going on here, mostly because this object is not hot enough to produce emission lines, and there's also no star around it to excite methane to then produce these emissions. So what's happening then? Why was methane glowing? Well, it's still not entirely clear, but there's one explanation. The only explanation we have about methane emissions involves aurora. Or basically this brown dwarf potentially has very powerful aurora in its atmosphere, kind of similar to Jupiter, that excite a lot of methane around it, making it extremely bright in certain frequencies, which is what we're seeing with the James Webb. And though brown dwarfs by themselves can actually have very powerful magnetic fields, normally we don't expect them to produce aurora unless there is something else interacting with them. But there are no stars here, and nothing else in the vicinity that could make this happen. So what's causing the aurora then? And here we once again have only one explanation. That one is actually from Jupiter once again. We know that aurora on Jupiter are sometimes caused by the solar wind, but more often are caused by its moons, Io, Europa and Ganymede, with Io actually having the most influence. And that's because Io has a lot of volcanism, which ends up releasing a lot of sulfur that then interacts with Jupiter's magnetic field, creating the aurora we observe. With one implication here being that maybe this object has moons, although technically they'll actually classify as exoplanets because this is a brown dwarf, making this a primary object. And so if it does have some kind of an exoplanet in its vicinity that seems to produce these aurora observations, it would make it one of the most exciting objects we've discovered. Here the exoplanet would have to be really close to this brown dwarf and would also very likely interact with it in a lot of different ways, including tidal effects, which might cause very similar effects to what we see on Io, making the planet by itself relatively warm on the inside. And if it just so happens that it's massive enough and contains a lot of ice on its surface, it might even be similar to some kind of a very massive Europa, basically an ice world with really warm conditions inside and a really massive warm ocean. I mean, that's basically the best case scenario. Alternatively, it's similar to Io and has a lot of volcanism, but that's also still exciting. Either way though, because this object is kind of far away, it's kind of impossible to detect this planet or this moon through direct observations. And so additional studies have to be conducted by observing maybe some kind of a period or some kind of a cyclical nature to this aurora, which would indicate something in orbit. But that also means that we would have to look at it for a very long time, possibly a few months. Right now, because the James Webb Space Telescope is kind of booked for many months ahead, we're probably not going to be seeing or hearing about this for a very long time. Nevertheless, a really exciting discovery. A brown dwarf that potentially has its own relatively close planet, with both objects very likely affecting each other in a similar way to how Jupiter affects Io. And something we'll discuss more if there are any updates. But these are just some of the recent discoveries from the last few months, and we'll most likely have even more in the next year or so. And because brown dwarfs are so mysterious and because we know so little about them, I'll definitely be talking more about this in some of the future videos. Mostly because I really find these objects super fascinating. And so until those future discoveries or until we find something else, check out additional videos about brown dwarfs in the description below. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.